Okay, let us start chemical property of chlorine. We already complete up to this reaction. Okay, that what happen when chlorine gas react with hot or cold dilute alkali. Okay, now let me start with here that chlorine when react with dry slake lime, it gives bleaching powder. Okay, and the formula of bleaching powder is CaOCl2 dot CaCl2 dot CaOH twice dot 2H2O. Okay, it is already completed. Now chlorine react with hydrocarbon. Okay, methane, ethane, ethene, propane, butane, pentane. Okay, so whenever it react with methane or any hydrocarbon, it form alkyl halide. Okay, see, with saturated hydrocarbon, it gives substitution product, means one chlorine is added and one element from hydrocarbon is removed. Okay, so whenever alkane react with chlorine, it form addition product. Okay, sorry, substitution product. CH4 plus Cl2 gives CH3Cl, that is methyl chloride and HCl gas. When chlorine is react with unsaturated hydrocarbon, okay, double or triply bonded hydrocarbon, alkene or alkyne, so it gives addition product. Nothing is removed, only addition take place. So with ethene, it form 1,2-dichloroethane. Okay, now chlorine water on standing lose its yellow color due to the formation of HCl and hypochlorite, that is HOCl. This hypochlorite is responsible for oxidizing and bleaching property of chlorine. With chlorine with iron sulfate oxidized to sulfite. Okay, here see oxidation state of Fe is increased. Also, it oxidizes sulfur trioxide to sulfur sulfate. Okay, here sulfur SO3 to SO4 conversion take place with the help of chlorine. It is already completed. Oxidation of SO2 to SO4 also take place with the help of chlorine gas. With iodine gas, it form periodate. Okay, HiO3. Here oxidation state of iodine is increased from +1 to +3 and +5. Chlorine is powerful bleaching agent. Bleaching action of chlorine is due to oxidation reaction. Okay, it is also bleach vegetable or organic metal in the presence of moisture. Okay, bleaching effect of chlorine is permanent, it is not temporary effect. For example, see, whenever chlorine react with vapor, it form HCl and O. This oxygen remove color from any substance and make them colorless. Okay, now next is uses of chlorine gas. It is used for bleaching wood pulp, bleaching cotton and textiles, Okay, bleaching as a bleaching agent in cotton textile industry, okay, and paper industry. In the extraction of gold and platinum, also in the manufacturing of dyes, drugs, and organic compounds like carbon tetrachloride, chloroform, DDT, refrigerants. Okay, it is also used in sterilizing drinking water, also preparation of poisonous gas like phosgene, okay, COCl2, tear gas, CCl3NO2, and mustard gas, Cl, CH2, CH2S, CH2, CH2Cl, okay, thiodiethyl chloride. Now our next point is oxo acid of halogen. Okay, hydrochloric acid is not there in your syllabus, so we start from oxo acid of halogen. So due to high electronegativity and small size, fluorine form only one oxo acid, that is HOF, known as fluoric acid 1, okay, or hypofluorous acid. The other halogen form many oxo acid. Most of them cannot be isolated in pure state. Okay, they are stable only in aqueous solution. We cannot isolate them as a pure ઓક્ઝો એસિડ એને આપણે શું કરવું પડે એને વોટરમાં એને સ્ટોર કરેલું જ રાખવું પડે ઓકે they are stable only in aqueous solution aqueous ફોર્મમાં જે સ્ટેબલ છે or in salt form. See, halic 1 acid in which oxidation state of halogen is +1. So hypofluorous acid, hypochlorous, hypobromous, and hypoiodous acid. Here the oxidation of halogen is +1. Then halic 3, oxidation state of oxygen is +3. Okay, HOClO, chlorous acid. Then halic 5 acid +7, HOClO2, HOBrO2 or HBrO3, HClO3 or HiO3, iodic acid, bromic acid, and chloric acid. Then halic 7 acid +7 oxidation state of halogen, HClO4, HBrO4, and HiO4, or we can say HOIO3. Okay, so these are the acid having different oxidation state. આ જે રોમન લેટરમાં 1, 3, 5 and 7 છે એ હેલોજનનો ઓક્સિડેશન સ્ટેટ બતાવે. See the structure of oxo acid: hypochlorous, chlorous, chloric, and perchloric acid. Okay, you have to remember this structure also. Enter halogen compound is not there in your syllabus. So our next point is element, last point, element of 18 group element. Okay, 18 group element start કરીએ હવે. So 18 group elements માં કયા elements આવે? So it is helium, neon, argon, krypton, xenon, radon. Okay, so these are the element of 18 group. All are unreactive. Okay, and it is also known as noble gas. Occurrence is not there in your syllabus, so we start with properties. Okay, so first is electronic configuration. The general electronic configuration of 18 group elements is NH2 NP6. Okay, except helium, it is 1s2 only. Now, ionization enthalpy. Now, electronic configuration of 18 group is stable. Okay, so the energy required to remove electron from stable electronic configuration is very difficult. Therefore, the ionization energy of 18 group is very high, okay, compared to other elements. However, it will decrease down the group because of increasing the size of element. Okay, when we move from top to bottom, the size of element is increased, and therefore the ionization energy or enthalpy of 18 group is decreased. If the question asks that why the ionization enthalpy of 18 group is very high compared to other elements or other group elements, the reason is stable electronic configuration. Okay, you have to mention this reason. Second one is atomic radii. Okay, atomic radii, same trend, increase down the group. Next one is electron gain enthalpy. Now see, noble gas have stable electronic configuration. Okay, so they have no tendency to accept any electron. So if we want to add an electron to 18 group, then more energy have to apply. Okay, exothermic reaction must be endothermic reaction is take place. એનર્જી આપણે આપવી જ પડે એમાં સ્ટેબલ ઇલેક્ટ્રોનિક કન્ફિગ્યુરેશન જરૂર નથી એની અંદર આપણે ઇલેક્ટ્રોન એડ કરવાનો છે ઓકે સો એના માટે તો આપણે બહારથી એનર્જી આપવી જ પડે ઓકે સો પોઝિટિવ વેલ્યુ છે આની સો આ પણ ક્વેશ્ચન પૂછાય વાય ધ ઇલેક્ટ્રોન ગેન એન્થાલ્પી ઓફ 18 ગ્રુપ એલિમેન્ટ્સ ઇઝ મોર પોઝિટિવ કમ્પેર ટુ અધર 17 ગ્રુપનું નેગેટિવ જોયું 16 ગ્રુપનું નેગેટિવ જોયું ઓકે તો આ બધાની નેગેટિવ છે જ્યારે 18 ગ્રુપની પોઝિટિવ છે એનું રીઝન એ જ કે એની જોડે સ્ટેબલ ઇલેક્ટ્રોનિક કન્ફિગ્યુરેશન છે એને જરૂર જ નહીં હવે કોઈ ઇલેક્ટ્રોનની તો હવે જરૂર નથી એમાં આપણે એનર્જી ઓકે કોઈ બેન્ચીસ પર બે સ્ટુડન્ટ મેક્સિમમ ઓક્યુપાઈ થતા હોય એની જોડે બે સ્ટુડન્ટ છે તો આપણે ત્રીજો સ્ટુડન્ટ જો એમાં એડ કરવો હોય તો આપણે ત્રીજા સ્ટુડન્ટે પોતે એનર્જી આપવી પડે ઓકે અને બેસવું પડે ધક્કો મારીને તો આ જ આવું જ કંઈક 18 ગ્રુપના એલિમેન્ટ્સ માટે છે 18 ગ્રુપના એલિમેન્ટ્સમાં પણ કેવું છે કે જો એમને એડ કરવો હોય ઇલેક્ટ્રોન તો પરાને એડ કરવો પડે ધેટ્સ વાય it shows large positive value of electron gain enthalpy. Now, physical property. So, physical property and chemical property is not there in your syllabus. Okay. આની અંદર ખાલી આપણે જે ઝેનોન ફ્લોરિન કમ્પાઉન્ડ અને ઝેનોન ઓક્સિજન કમ્પાઉન્ડ છે એ સ્ટડી કરવાનું છે બીજું કશું જ છે નહીં આમાં ઓકે સો આજે લાસ્ટ પોઈન્ટ છે એ આપણે ડિસ્કસ કરી લઈએ એટલે આજનો યુનિટ પૂરો થઈ જશે xenon fluoride and xenon oxide compound okay so let me start with xenon fluoride compound xcf okay xenon fluorine જોડે કયા ટાઈપના કમ્પાઉન્ડ ફોર્મ કરે so xenon form three binary compounds fluorides xcf2 xcf4 and xcf6 okay by direct reaction of element under appropriate experiment condition see when xenon in excess react with fluorine xenon નું amount વધારે છે okay 100 molecule xenon ના તો 50 molecule f2 ના okay at 673 kelvin and x 1 bar pressure it forms xenon fluoride when the ratio means amount of fluorine is more compared 5 times more compared to xenon and it react with at 873 kelvin temperature and 7 bar pressure it forms xenon tetrafluoride xcf4 okay and when fluorine is in excess amount where 120 times more compared to xenon and at 570 kelvin 73 kelvin temperature and 60 to 70 high pressure okay at that time they form xenon hexafluoride xcf6 okay Another process by which we can form XeF6 is reaction with of xenon tetrafluoride with O2F2 at 143 Kelvin. It forms XeF6 and dioxygen gas. Okay. Physical property of all xenon fluoride compound are colorless, crystalline solid and sublime readily at 298 Kelvin. Sublimation means directly it convert into solid to gas, okay, without passing in a liquid stage. Liquid આવે જ નહીં, આપણે normal solid to liquid and liquid to gas conversion જોયું, પણ xenon કેવા છે, sublimation આપતા compound છે જે directly convert શામાં થશે, solid to gaseous. Okay, they are powerful fluorinating agent. Fluorine add કરવું હોય તો xenon fluoride compound use થાય. They are readily hydrolyzed even in trace of water. થોડો પણ water હશે તો પણ એ easily hydrolyze થઈ જશે. Okay, and gives xenon, hydrogen fluoride and oxygen gas. See the equation. When xenon fluoride react with water, it forms xenon, hydrogen fluoride and oxygen gas. The structure of 3-xenon fluoride can be deduced from the valence shell electron pair repulsion theory. Okay, and these are shown below. Okay, xenon difluoride and tetrafluoride have linear structure, a linear and square planar structure, while XeF6 has 7 electron pair. Okay, lone pair of xenon and 6 electron of bonding between Xe and F, and therefore it is distorted octahedral structure. Okay, xenon fluoride react with fluorine ion acceptor to form cationic species and fluoride ion donor to form fluoroanion. See, proton acceptor with proton acceptor is formed XeF plus. Okay, XeF2 plus PF5 gives XeF plus. XeF4 plus antimony pentafluoride, it gives XeF3 plus. Okay, and with metal fluoride with donor it form anions, fluoroanions, that is XeF7 minus. Okay, we can use sodium, potassium, rubidium or cesium as a metal fluoride. See the figure, linear XeF2 linear, XeF4 square planar and distorted tetrahedral of XeF7. You have to remember this structure for exam, it is very important. આ પૂછાય છે એક્ઝામમાં સ્ટ્રક્ચર ઓફ. Next one is xenon oxygen compound. Okay, hydrolysis of XeF4 and XeF6 with water gives XeO3. See, XeF4 with water it form XeO3 and xenon and hydrogen fluoride and oxygen, while with XeF6 it hydrolyzed to give XeO3 and hydrogen fluoride. Partial hydrolysis, okay, of XeF6 gives oxyfluoride, XeO4 F4 and XeO2F2. It is there in your textbook. See, XeF6 xenon hexafluoride with water, partial hydrolysis gives XeOF4 and hydrogen fluoride. Okay, also it form XeO2F2. Okay, XeO3, structure of XeO3 is pyramidal, while structure of XeOF4 is square pyramidal. It is there. Now, XeO3 is colorless explosive solid and has pyramidal molecular structure, while XeOF4 is colorless volatile liquid and has square pyramidal structure. You have to remember the structure of these two compounds. Okay, uses is not there in your syllabus, so no need to read these uses. Okay, now our unit is over. chapter number 7.